We're now going to turn our focus to part 2 of the discussion on key concurrency and scheduler operators that are used in the context of the RxJava Single class. In general, these types of operators are arranged to run other operators in designated threads and/or thread pools. In this particular case, we're going to be focusing on the Schedulers.computation operator. This operator returns a scheduler that hosts a fixed pool of single-threaded executive service-based workers that's suitable for parallel work. Here's a code snippet we'll look at in more detail when we get to the case study at the end of this lesson. This particular code snippet shows how you can create a single that emits the results of multiplying 2 big fractions together in a thread from a parallel thread pool. We use the single from callable factor method operation to actually perform the multiplication of the 2 big fractions. And then we use the subscribe on operator in conjunction with the Schedulers.computation factor method to ensure that that computation takes place in that particular parallel thread pool. The thread pool that's used by the Schedulers.computation operator is optimized for fast-running, non-blocking operations. In other words, it's intended for computation-intensive processing, not IO-intensive processing. If you want to do IO-intensive processing, you should use the IO thread pool instead. The implementation of Schedulers computation is done using daemon threads that won't prevent the app from exiting, even if the work being processed in those daemon threads hasn't finished running. You can learn more about daemon threads in Java if you read the link at the bottom of the slide. This operator can often be used in conjunction with the observable flat map concurrency idiom. We'll be focusing on this idiom later when we get to the observable portion of this course. For right now, here's a little snippet to give you a preview of coming attractions. We use the observable flat map operator, which takes every one of the big fractions that's emitted using the from iterable method or factor method operator that's defined on observable. And then for each of those big fractions, we go ahead and schedule a computation to run in the computation thread pool in order to multiply those big fractions together. After the computations are all run in parallel using the concurrency idiom provided by FlatMap, it's converted back into an observable, and then we perform a reduction using the big fraction add method to add up all the results. Project Reactor has a scheduler's parallel method that's quite similar to the scheduler's computation method that's defined in RxJava. Once again, it's a bit of a mystery why they have different names for things that work more or less the same, but you just have to get used to that if you're going to be moving between these 2 reactive streams implementations. So that's the end of our discussion of key concurrency and scheduler operators that are used in the context of the RxJava Single class.